Good morning, it's Mrs. Hebert from the Syracuse Academy of Science and Citizenship. In fourth grade math, we are in week 7, day 3. We have a few more days of our standard for NBT B6. Let's reread it. We're going to find whole number quotients and remainders with up to 4-digit dividends and 1-digit divisors. We can use strategies based on place value, properties of operation, relationship between multiplication and division. We can also illustrate by using equations, arrays, and area models. Okay, and I'm going to show you again all 3 strategies that I had taught you the past few days. Let's go ahead and start. We have our first equation. All right, here we go. Liam has 492 baseball cards. He splits them equally between himself and 2 friends. How many baseball cards does each person get? We're going to read it again. Liam has 492 baseball cards. He splits them equally between himself and 2 friends. How many baseball cards does each person get? Think of your cube method, okay? We have, let's see, 492. He has his 2 friends, and himself is one other person. Don't let that trick you, because it says he's going to break them up between his friends and himself. Okay, we know we're going to underline our units, baseball cards, and we know he splits them equally. This means that there's going to be no remainder, and that he's dividing them between people. So we know we're going to divide, okay? So we are going to box how many baseball cards does each person get? That's what they want us to solve. We don't really need to eliminate. And today, we're going to solve. Here we go. We're going to use a standard algorithm. So I know himself and 2 friends is really 3 people. Okay. And we are dividing by 492. Okay. All right, our strategy, here's our anchor chart. We have our D, M, S, P, divide, multiply, subtract, bring down. Okay, let's start. How many times does 3 go into 4? If you notice, I kind of cheated. I put my multiples of 3 up here already. I know it goes in 1 time. Okay. 3, or 1 times 3, we get 3. Now we need to subtract. 4 minus 3, we get 1. And bring down. 19. Okay, let's start the process over. We did our 4 steps. We're going to repeat. Ask yourself, how many times does 3 go into 19? It's not even, but we're close. Ready? 1, 2, 3, 4, 5, 6 times. Gets us close to 19. 6 times 3, we get 18. Okay. Now we subtract 19 minus 18, 1, and we bring down the 2. Awesome. Next step, repeat. We're going to refresh ourselves. Here we go. Let's see if we can do it without even checking them, all right? We're going to ask ourselves, how many times does 3 go into 12? Let's look. Well, and we know this answer should not have a remainder because he's splitting them equally. So let's see if we did it right. 1, 2, 3, 4. Perfect. It goes in 4 times. 4 times 3 is 12. And when we subtract 12 minus 12, we get 0. We're done. There's nothing else to bring down. Our quotient is 164. Okay? So I want to show you. We're going to check it really quick. Let me move this out of the way. Okay, we have 164 times 3. 4 times 3 we know is 12. Carry that 10. That lets me. 6 times 3, 18, and 1 more is 19. Carry that. 1 times 3 is 3, and 1 more is 4. 492, we know we have it correct. You might also see, they might show you a tape diagram, and they might say to you, let's change this color, so if this whole thing is 492, and there's 3 pieces because there's 3 friends, what does each piece get? And that would be our quotient, 164. 164. 164. That's just another way to show it. 164. Okay, that's a tape diagram. Awesome. Okay, so we're going to stick with the same equation today, and I want to show you again the place value dis and also the open area model. Okay, let's start. Let's do the place value dis first. So we have our hundreds, tens, ones, HTO. All right, so like I said, we're going to stick with the 492 divided by 3. I'm going to show you how to do it. We got how many hundreds? We have 4, 1, 2, 3, 4. 9 tens, which is 90. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2 ones. Okay? We know we need to break it into 3 groups. Okay, 1, 2, 3. Okay, so if I have 4, each group gets 1, 2, 3. I have a leftover. So we know that this becomes tens, and there should be 10 tens and 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 5, 10, 15, 19. If I have 3 groups of 19, I know a multiplication fact. I know that 3 times 6 equals 18, so it's close. So each group is going to get 6. 6, 2, 3, 4, 5, 6, 3, 4, 5, 6. Awesome. So we would use 18 of them, which will give us 1 left over because there was 19. Okay. So that left over, we know it becomes ones. How many ones are in a 10? If you know it, yes, there's 10 ones in a 10. 5, 6, 7, 8, 9, 10. We have 5, 10, 12. 3 groups of 12. My multiplication fact I know is 3 times 4 is 12. So each one gets 4. Oops, let's put that one where it would go. Okay, perfect. So each group, let's see, each group has 164, just like we got with the other answer. Okay, now let's also do that open area model. All right, here we go. So remember, when we do our open area model, let's get our rectangle going. Okay, perfect. Remember, it doesn't have to be perfectly to scale. But let's look. So if we're dividing 492 divided by 3, okay, we know that 4 is in the hundreds place, right? So basically, we have 492 in our whole area. we know we can say this side is 3. So 3 times what? So we want to know 3 times blank equals 492. Okay. All right. So if this is the hundreds place, we know that 3 times 100, right, is 300. Okay, so 492 minus 300. What do we have left? You could probably do it in your head. If not, go ahead and show that. So we could do, let's get rid of this so we can see it. Just give me a moment. Perfect. Okay. So we have 492 minus 300. We have 192. Okay, some of you knew that in your head. Now, I have 19 tens, so that 9 is in the tens place. So I know that 3 times what can equal almost 19. So I know if I did 3 times 6 is 18. So what about 3 times 60? I get 180. Okay, so 192 minus 180. It's okay. The colors are going to be different. We have 2 and 12. 12. Okay, so now basically I know that 3 times what equals 12? 3 times 4. Okay, and guess what? 12 minus 12 is 0. So we have nothing left, so we're done. So our answer would be, let me give you a different color to show you, 164. Bam. So you choose today on your exit ticket standard algorithm. You can use the open area model or place value dis, whatever you prefer, okay? And have a great one. Mrs. Hebert saying goodbye. See you guys tomorrow.